Questions 10 and 11 are based on the following. The heart disease death rates per 100,000 people in the United States for certain years, as reported by the National Center for Health Statistics, were. I took that information and I put them directly into my lists of my calculator, keeping the year as the x variable and the death rate as the y variable. Though remember, for any value involving correlation or r squared, they could have been reversed. Number 10. Which one of the following is a correct interpretation of r squared for the least squares regression line for the above data? So that tells me to interpret and calculate the regression line. And I've got that regression line calculated. Remember, I used number 8 on my calculator so that A represents the y-intercept, B represents the slope, and most important here is that I'm finding the value of r squared, that proportion of variability. The most common mistake in this problem was to have chosen the value of r that does have a negative value because the actual death rate was falling over time. So if I keep my key value of r squared equals 0.9627 and then look at our answers, approximately 0.962728. C, the regression line explains 96.28% of the variation in heart disease death rates. That explaining the variation or variability is the key definition of what r squared is. So letter C is our correct answer for number 10. For number 11, I'll go back to where we were asked, first of all, based on the regression line, what is the predicted death rate for the year 1983? A weakness in this question is it does not tell you where to round these decimal values for A or for B. So I'm going to recalculate that by doing a linear regression. Number 8, but I'm going to tell it this time to do it for list 1, list 2, and to paste it directly into y sub 1 so that I can keep as much accuracy as possible. Once that value then has been calculated, it is directly in my y equals with all the place values the calculator is able to hold, and I'm going to look for the key value. It asked about a value for the year 1983. So I need to substitute 1983 in place of x, and I can allow the calculator to hold those place values. Under my table setup, if I change the independent variable to ask, when I then go into my table, second graph, I can put in any year here, 1983, and it'll produce the value. We get 195.42. That was per 100,000 people based upon the information in the given set of data. And since that is not any of our values, E would be the correct answer. On this test, I allowed each of these two answers as well because it really depended upon your rounding, and as I saw people on their paper put the actual calculation down, I felt that that was a fair solution to some poor wording of that particular question.